Greetings, math fans. All right, so we're going to start graphing some polar graphs. These are actually pretty cool graphs. I'm going to bring up my calculator here on the screen and just kind of make sure you have your TI with you and just kind of follow along. All right. So here's my calculator. The first thing I need to do here is I need to get into the right mode. And it's just, again, it's kind of cool. We're using some different modes here. But hit the mode here, which is next to the second button, okay? And what you want to do is then cursor down, and you see where it says, right here, it says Func, Par, Pol, and SEQ. Okay, you're going to cursor over to Polar. And it's kind of nice because as I click a button here with my cursor, it turns red, so you can kind of see what button I'm pushing. Anyway, hit Enter and change it to Polar, all right? And then quit out of here. And now when you hit y equals, instead of y equals, look what shows up, r equals, which is perfect because that's what we're graphing. We're graphing r equals. Those are some of the equations. Remember we did just by converting equations back and forth. Now everything is r equals. All right. So let's look at the sheet here that I made for you guys, and we have r equals 5. So let's just put a 5 here. R equals 5. Now let's talk about some of the zoom keys because some of you guys maybe are not even that familiar with how to do all the zooming. The best one to use, if I hit zoom and zoom 6 like brings it into, let's say it's, you're trying to get a good picture of what it looks like. It actually kind of finds part of that graph, and sometimes it doesn't do a great job, but you do zoom 6 and it actually puts it right in the middle. Found the graph and it put it right in the middle. Now, the only problem with this is, first of all, sometimes it's really small and you can't see it. So let's look at another zoom key. If you hit zoom and you cursor down here, zoom fit, zoom 0. Okay, that's kind of nice because that kind of fills the graph or fills the screen with the graph. So zoom 0. But still, it's not that great of an equation. In fact, r equals 5 is a circle, and this is certainly not a circle. This is an ellipse. Here, this is what's going on here, math fans. Is unfortunately on your TI, the screen is not a square screen; it's a rectangular screen. So when I do zoom fit, it tries to fill the rectangular screen with the graph, and you can even see that the X tick marks on the X-axis, they're a lot farther apart than the Y tick marks on the Y-axis. Okay, so what I want to do, the best one here, if I hit zoom, and if you guys see zoom square actually squares it off. It makes equal tick marks. So if I do zoom 5, okay, now the X tick marks are the same distance apart than the Y tick marks, and this is actually my graph that I get. Okay, so I get a circle. So I want you guys, just to graph it, right? We're just making a sketch here. Tomorrow, we're going to actually do graphing by hand, but today I want you to just recognize what it is. So r equals 5 is a nice, friendly circle. Okay, that's cool. All right, let's take a look at the next one here. R equals 4 cosine of theta. So let's go hit that, and we have r, and clear that out of here, 4 cosine of theta, and the xt theta n, that's your theta button, okay, instead of, because we're in polar mode now. So close parentheses, it's good habit. And once again, if I hit zoom 6, that's at least brings it into what you should see here. It's kind of small, so again, I like zoom 6. I like zoom fit. So zoom fit, you can just type in 0 because I know zoom fit is 0. And look what it does. Oh, okay, so it's, well, I'm not sure. Is that the right graph? Let's go. Let's do one more thing here, right? If I do zoom square, zoom 5. Look at that, boy. Okay, so I have a circle on the right-hand side of my XY grid. So this is kind of what it looks like. I have a circle like right here. It's not drawing it that great, but it's okay. The one thing I want you guys to see about symmetry, it says comment on symmetry. What is symmetric about? It's symmetric about the x-axis, isn't it? Interesting, interesting. Well, keep that in your mind, okay? And also keep in mind this nice little word, cosine here, okay? So it's 4 cosine of theta is symmetrical about the x-axis. Let's do this guy right here. 2 sine of theta. Okay, let's move this over. Okay, y equals, it's cleared out, 2 sine of theta. Close it. And if I just hit graph, this is what would happen. I just want to show you. Okay, see, it's kind of like, I mean, you're lucky you got it in there, but sometimes it doesn't quite fit in there. It's like way off the chart. So what I would do is, you know, again, you can do zoom standard, zoom 6, and that it kind of puts it more in the middle. But boy, again, it's really small. So let's do zoom fit. Okay, again, another ellipse. I don't know if that's really the right look here. So if I do zoom square, which is zoom 5, it actually puts it into what it's supposed to look like. Okay, so that's a circle above the x-axis, and it kind of cuts right. The y-axis cuts in half. So this one looks kind of like this. So what is this symmetric about? This is symmetric about the y-axis. And notice this. Okay, so what can you tell me? Well, r equals 5. Don't you guys agree it's symmetric about the x and y-axis? Or axes? Okay, because it's like right in the middle. Okay, but 2 is symmetric about the x-axis. It's cosine. Remember, cosine is x over r. Y sin is y over r. So that's just really easy. You know with the symmetry right off the bat. If it's sine, it's the y-axis. If it's cosine, it's the x-axis. Okay, but all the above graphs are called circles. Okay, so notice, well, this one, the r equals 5 is pretty easy. The other two, just look at them. It's 4 cosine theta, and number 3 is 2 sine theta. Okay, so let's take a look at some of these other ones now. That's a little bit different, but let's graph this guy. Okay, so we get clear this out here, and we get 3 plus 3 cosine of theta. Okay. And let's do zoom standard first. Interesting. So let's do, how about zoom fit? Zoom 0. Let's actually get the best look. Zoom 5 is zoom square. So what does it look like to you? It's kind of like a heart, isn't it? Okay, and it actually is a heart, and we call it a cardioid. So it's kind of a sideways cardioid. That's when you draw a normal cardioid when things are really good with your boyfriend or girlfriend, but if things are a little rough, a little rocky, you draw a sideways one saying, hey, you better be delivering me some candy and flowers here if you want to fix things up a little bit, okay? So anyway, this guy here, in fact, just because I want to do it, it's going to kind of look like this. Well, that's kind of bad. Okay, but the thing I want to point out here, guys, it doesn't look like this. It doesn't come to a point, okay? It's not truly a Valentine. Okay, so don't draw a heart like that. It's really a rounded edge over here. So draw it somewhat correctly, okay? But this is, so let me even title this now. This is a cardioid, C-A-R-D-I-O-I-D. Because think of, what's a heart doctor? A heart doctor is a cardiologist. Cardioid, heart. Okay? All right, let's do this next one here. 2 minus 2 sine of theta. Let's bring up the calculator here and type that one in. So we got, okay, so we clear it. We get 2 minus 2 sine of theta. Okay, and then we do zoom 6. This is much nicer. Let's do zoom fit again. Excellent. Oh, now that's what we really want. And if I truly do a nice zoom square, that actually kind of makes it more proportional to what we want. And so that guy is truly what a cardioid looks like. Okay, so if you're sending Valentine's Day cards out to people, this is what you want to do. Like that. Okay, it kind of goes in like that. Yeah. Okay. That's it. So let's take a look at our, right? Looks pretty good. So you're just, again, kind of making a rough sketch, but that's kind of nice. Notice the symmetry here again, math fans. Remember I told you cosine is x, and sure enough, it's symmetrical about the x-axis. And look at this one, it's symmetrical about the y-axis. Okay? So that's pretty good. And then, if you change things around, it's not like, we don't have a graph like this, but watch this. See, I have 2 minus 2 sine of theta. What happens if I change that instead of 2 minus, I change to 2 plus sine of theta? It's still going to be, obviously it's a cardioid, but let's look what happens here. Let's do zoom, I think we can just do zoom square here. Now let's do the whole routine here. So zoom standard. Interesting. Zoom fit. Boo, it's upside down. Okay, so that's what happens when you switch. Basically, when I switched this sign right here, it made it an upside down cardioid. All right, so that's when you're saying it's pretty much all over. Okay, you send the upside down cardioid. It's all over. So and it also looks a little kind of butt cheeks, but whatever. All right, so this is a cardioid. What is common? What do you see as common between these guys? Well, I see a 3 and a 3, and I see a 2 and a 2. Some's negative, some is positive. Keep that in mind. Okay, let's keep going here. We got a bunch of graphs that I want you just to kind of see what's going on here. Number 6, let's put that one in the graphing calculator. All right, so we're going to have y equals, clear that out of there. It's going to be 4 plus 2 cosine of theta. Okay, so we're going to do zoom 6, always a good one to do. That's kind of interesting. And let's do zoom 0 to fit it kind of on the graph. Okay, and then zoom 5 to make it nice and to square it off. See what it is. So it's interesting. You notice there's a flat spot right here on the left-hand side, like at coordinate -2, 0. Okay, so that's kind of what this looks like. Let me graph it here. It's kind of like a flat spot right here, and then it kind of goes around like that. It's not. I'm not the greatest drawer here, math fans. Okay, but when I start plotting points, I'm a lot better at drawing it. But it's kind of a flat spot here. It's like a guitar pick, if you want to think of it this way. Okay, so kind of keep that in mind. Let's take a look at the next one. 1 plus 5 sine of theta. Okay, let's graph it. Move this over. R equals 1 plus 5 sine of theta. And again, we're going to do zoom 6. Ooh, that's kind of cool. And let's do zoom fit. All right, nice. I like that. And then zoom 5 to kind of square it off. So this is what the deal is. It looks like this. We have a big loop and then a little loop inside. Okay, and again, it's our axis here. Symmetry is easy, right? Again, cosine, it's symmetrical about the x-axis. And sine, it's symmetrical about the y-axis. So that's pretty mellow. All right, so all of these graphs, including the cardioid, these are called limacons. Limacon is a French word. And truly, to make it French, you put this little, I don't even know what it's called. So you put like a bottom part of a 5 below the C. I'm not looking for that. I just think it's kind of cool. It's a French word. Okay, you say it. You can even say it more French. You go, yes, it is a limousin. Okay, and if you really don't have the accent and you're kind of saying maybe from the south a little, you're going, that's one of them. They're lamacons. Try to say limousin. Sound a little more Frenchy over there, and you're going to do okay. All right, but these are limacons, and this guy right here. this is called a limousin without a loop. And this one is a limousin with a loop. Okay? And a cardioid is a type of limousin. But you're going to either give me one of three things here, math fans. You're going to tell me it's a cardioid. You're going to tell me it's a limousin without a loop, or a limousin with a loop. Okay? And you should be able to recognize what's what with this. So let's kind of, I have a little way of having you guys remember this stuff here. But what I want you guys to do is, let's take a look at this next part right here. Consider these equations, and these are pretty much, you had your A and your B, and it's either sine or cosine. Let's compare. If A is equal to B, and so go back to here, do you guys agree? Number 4 and 5, A is equal to B. The absolute value of A is equal to absolute B. All right. If that's true, it is a cardioid. Okay? And the way I have people remember that is if the letters are, if the numbers are the same, then there's true love. Oh, they're the same, so it's true love. Okay, cardioid, so they're the same. If A is greater, so we have, let's compare these two. So I'm going to look at this 4 and I'm going to look at this 2. So let's actually do this one first. So do you guys see that the 4 is greater than 2? And we're going to say that for last. And see that 1 and the 5? Again, I don't care about the signs. I don't care if it's positive or negative. It doesn't matter to me. I'm strictly, in fact, I look back down here. I'm strictly looking at the value of A and B, no sign. So let's do, we're doing this bottom one here first. If A is less than B, I always say, let's look at this guy. That's this guy here. This guy. So less is loop. Less is loop. Okay? Less is loop. So that's how you remember that. If that number is less than that, it's, so here, another example could be R is equal to negative 2 minus 7 cosine of theta. Less is loop. That would be a limousin with a loop. Less is loop. Okay? Just a different look, different symmetry, whatever, but less is loop. It's a limousin with a loop. All right. So this is a limousin with a loop, or with loop. Okay, because less is loop. All right? Now, oh, it's my favorite. This is also limousin, so we're going back to this guy here. So this has no loop, right? Greater, if it's greater, it has no loop. Now, when I first came up with this, I said less is loop, and that was just a good way to remember it. And then I'm the greater. I'm like, is there a good way as opposed to, yeah, if it's less is loop and the other one is greater, it has no loop. But then I came up with something, if it's greater, so L, less is loop, greater, G is get out of here, loop, but you have to hold your fist up and you got to just kind of say it loud. Get out of here, loop. I think it's just a really effective way to do it. So let's come down here. Limousin, if A is greater, so this is a limousin without a loop. So greater is get out of here, loop. Get out of here, loop. It's very scary. All right. So again, I don't care about the signs. So let's just, if I have an example, R is equal to negative 3 minus 3 sine of theta. What is it? Cardioid, same number. Ooh, this is still a cardioid. It's still a cardioid. As long as that number is the same, absolute value, it's the same. It's cardioid. Same number, true love. So it's just two of a kind. Okay, same, husband, wife, whatever, however you want to look at it. True love. Okay, and then if I said R is equal to negative 2 minus 5 cosine of theta. Again, I don't care about that. I don't care about the negative. I care about that number and that number. And what is it? 2 is less than 5. So less is loop. So this is a cardioid. Less is loop, so it's a limousin with a loop. Okay, and then here r equals negative 7 plus 2 cosine of theta. So 7 is negative. Again, I'm only concerned with this guy right here, that and that. I don't care about the signs. So do you guys agree 7 is greater than 2? And what does that mean? Get out of here, loop! So the loop's is going away, so it's a limousin without a loop. So it's a limousin without a loop. Okay, so that's the way to identify that. All right, next thing. This is actually kind of cool stuff. I like this one. Comment on symmetry. State the number of petals and how long each petal is. Ooh, petals. Sounds exciting. All right, well, let's pull up our graphing calculator here. And let's clear this out. And we get r equals 4 sine of 3 theta, close parenthesis. Okay, and then we're going to do zoom 6. Cool. All right, so let's zoom in a little bit more. So let's do zoom fit. And let's make it nice and square here. So zoom 5. And that's truly what the graph should look like. Okay. Notice we've got sine. What is the symmetric about? Y-axis. Okay, so it's y-axis, which is typical because it's sine. Okay, and so this has got 3 petals. So let's, if I kind of sketch this, it looks kind of like this. Not the best. Whoa, that's a little rough. Okay, but that's kind of a. It's called these are all called roses, by the way. So we can even look at this. These graphs are called roses or a rose. Okay, so let's keep going here because there's some information. First of all, I said state the number of petals and how long each petal is. Well, let's go back to the graph. And how long does it look like each petal is? Well, let's look at this one down. This is kind of nice. One going down here. It's 1, 2, 3, 4. Interesting. So this 4 right here, that's the length of the petal. Okay, that's pretty easy. And that 3 must be the number of petals. Interesting. Okay, so how many petals is this one going to have? 5? I don't know. Let's test it out. It's r equals. So let's put in here. Clear it. 6 cosine of 5 theta. Oop, I didn't get the 6 in there. You guys know how to insert stuff, I hope. Like I'm in this pot here. If I hit second, delete. It changes my cursor now, and now if I hit a 6, it puts it right in there. Oh yeah! So hopefully you learned a couple things here. Anyway, let's do zoom 6. Ah, look at that, 5 petals. Let's zoom fit. Okay, and then let's do zoom square just to kind of get a nice look. So that's kind of what it looks like. It looks similar to this. So it's 1. Okay, like that. 3, 4, and 5. Not the greatest drawing in the world, okay? But something like that. And this one's, of course, symmetric about the x-axis. Okay, so 5 petals. And this is 3 petals. Okay, and of course the length of the petal is 6. Alright, so let's keep going here. That's very interesting. 3 sine of 4 theta. So 3 sine of 4 theta. Zoom 6. Whoa, 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 whoa. It's supposed to be 4 theta. That's supposed to be 4 petals. Let's zoom in a little bit on that thing. How many do I have here? 1, 2, 3, 4, 5, 6, 7, 8. Interesting. I have 8 petals. So it's going to look something like this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's a little off here a little bit. It's okay. Okay, 8 petals. 8 petals. Okay, and the length of the petal is still 3, I believe. We can kind of check that real quickly. Okay, yeah, it looks like it's 1, 2, 3. It looks like it goes up to 3. That's kind of interesting. Why does that have 8 petals? Let's check out the next one out here. Y equals 4 cosine of 2 theta. So 4 cosine of 2 theta. Zoom 6. Interesting. Zoom 0. Let's do zoom square, because I think that's always a good one. So that's got 4 petals. Looks like this, like this, like this, and like this. 4 petals. Well, what conclusion can you make? Let's look at this number. This is a 4 and this is a 2, and this one has 8 petals and this one has 4 petals. Okay, so what can you say? How can you tell the number of petals without graphing the equation? Well, if it was a 3 here, okay, if that's a 3 or a 5, that's an odd number, isn't it? And you get the same number of petals. And if it's an even number, it's double. That's kind of interesting. So here we can make this conclusion then. Let's come down here. How can you tell the number of petals without graphing the equation? You can say if it's an even number, so even number before theta, okay, then it's double the petals, the number of petals. Okay, so it's an even number before theta, it's double the number of petals. If it's an odd number before theta, then it's just the same number of petals. So even number, but be like 2 theta, 4 theta, 6 theta, etc. And odd would be 3 theta, 5 theta, 7 theta. Well, there's a couple. First of all, I want to point out one thing here, math fans. Let's go back to the first graphs we did. See, it's r equals 4 cosine of theta. Boy, that's really close to a rose. It's a circle. In fact, that's a 1-petal rose. Okay, because isn't that really, it's 4 cosine of 1 theta, which is an odd number, which is a 1, if it's an odd, going back to this guy here, right, if it's an odd number, it's the same number of petals. So if it's a 1, we don't call it a 1-petal rose. I mean, you've ever seen a 1-petal rose unless it's dying? All right, so 1-petal rose we call a circle. Don't call it a rose. All right, and that's even a way to help you to remember that too, because sometimes people they forget. Is it even number that's double, or if it's odd number that's double? Just remember, if it's a 1-petal rose, which is a circle, you don't draw 2 petals. Okay, so it can't be the 1. It's actually the 2 or the 4 or the 6 or the 8 gives you double number of petals. Okay, so kind of remember that. Now, I want to talk about why that's the case. Why is an even number give you double the number and an odd number gives you single number? Well, here's the deal. Let's go back to this number 8. R equals 4 sine of 3 theta. So let's do that. Y equals, we'll clear out here, 4 sine of 3 theta. Okay, and let's graph it again, zoom 6, and let's zoom 0, zoom fit, and let's do zoom square, zoom 5. Okay, so this is what the graph looks like. Let's trace it. If I hit, well, first of all, let's see what mode we're in. I'm in mode, and I know it's polar, but I'm in radian mode. Let's actually switch that to degree mode, because it's just going to be easier to kind of watch that. So if I switch this to degree mode, and let's do the zoom again. So zoom 6, and zoom 0, and let's do zoom square, so zoom 5. So now we're in degree mode. And so let's hit trace now. If I hit trace, and see how we have our theta 0, x and y are 0? Well, what I want you guys to pay attention to is that theta is equal to 0. So as I cursor to the right, so you hit the right button now after you hit trace, and see it's 7.5 degrees, and watch the little dot going around tracing the rows. So it's 15 degrees, 22.5, 30, 45, 52.5, 60 degrees. You guys agree? I made that pedal by 60 degrees. Keep going. I'm going down the bottom pedal, and notice, math fans, I know I drew it like you can sketch it like really fast, but truly it's not sketching it each pedal and then going to the next pedal and going to the next one. It's actually going around and around and around. Anyway, so I'm sketching that second pedal, and I'm done with that pedal. That's 120 degrees. Sketching the next pedal. Sketching that. Oh, okay. I've sketched all 3 pedals, and I'm only at 180 degrees, but I need to go around to 360. So what's going on? Watch. So here's the deal, right? I am actually overlapping my pedals. So truly, even though it's an odd number, I'm actually creating 6 pedals, but I'm just overlapping one other set. So I know it's visually you only see 3, and that's what I want you to write down. How many pedals is 3? But I want you to understand it's not just miraculously creating a 3-pedal rows. It's actually it's going around twice. It's just when I do it an odd number is that way, but when I do an even number, there's no overlapping, right? So if I did r is equal to 4 cosine, of 2 theta, and let's do zoom 0. And zoom 5. It was already kind of in the right realm here. And now if I do trace, each pedal is going to be 90 degrees. Watch this. There we go, man, 90 degrees. And go to the next one. That's another 90 degrees. That's 180. And notice how it's sketching it. It did the top one, then it did the bottom right one, and then it did the left one, bottom left. At 270, and then it's going to do the top left one. And once it'll get all the way around to 360 and back to the start. Okay? So I want to make that point. If it's an odd number, then it's the same number of pedals. If it's an even number, it's double. Okay? But truly it's just overlapping it once when you're doing an odd number. All right. So I hope you guys learned something with this. You guys, we're gonna do the next day. We're gonna do it by hand. Being able to recognize if it's a rose or a limousin with a loop or a limousin without a loop or a cardioid or a circle. I think that's really important to be able to recognize all those different graphs. So that's why we did it on our calculator, and we learned a little bit about our calculator too. All right. That's it, man, fans. Have an outstanding day. Adios. Goodbye.